Hello everyone. My name is Pavan Nutalapati. So I am a senior technical lead at Oracle Corp. So today my topic is basically we'll discuss about quantum computing and then how it impacts on the cloud security and then how we should be prepared for that actually. This would be my topic. Now for many years quantum computing was something we thought as far off like maybe 10 or 20 years away, but that's no longer true. Quantum computing is moving from theory of reality very quickly. And as it does, it poses some serious risk to the cryptographic foundations we rely on today to protect the cloud environments. So, this talk is really about how we can start preparing now before the quantum computing starts breaking the encryption, like today's standard encryption, and it exposes the sensitive data. So, first of all, what is quantum computing? Right? So, let's dig in a little more detail in that. So quantum computing operates using quantum bits, or it's called qubits also. So unlike classic bits, which you know are zero or one, qubits can be both zero and one at the same time. It's because of the property called superposition. So they can also be entangled, meaning that the state of one qubit can be linked to another, allowing for highly parallel processing, extremely fast computation for certain type of problems. Now, why does that matter for security? Because quantum computers can run algorithms that are fundamentally different and far more powerful than the classic ones. Let's take an example. Shor's algorithm, right? And it allows quantum computer to factor large prime numbers exponentially faster than the classic computers. And this threatens RSA and then ECC encryption. This is basically the public key cryptography we use everywhere. It's ubiquitous in the cloud systems. So another example would be the Grover's algorithm. It can also get weakened by the symmetric encryption, right? So in short, quantum computing is game changer for cryptography. Now let's look at specifically how quantum computing threatens today's cloud environments. So today's cloud security relies heavily on RSA and ECC for public key encryption, for identity, key exchange, TLS, everything. A sufficient powerful quantum computer could use Shor's algorithm to crack RSA 2048 in minutes, completely breaking these protections. The cloud-based quantum computing market is expected to be worth around like $4 billion by like in few years. So we are actually in 2023, it's just 798 million. By 2028, in a couple of years, it's going to grow exponentially higher. So we discussed about the quantum computing. We discussed about what the qubits are, and then how it enables the massive parallel processing and all that. Yeah. So now let's talk about like how the quantum computing threatens the cloud security. Right. There are like three key risks I want to highlight. One is breaking public key encryption. Today's cloud security relies heavily on RSA and ECC for public key encryption, for identity keys, exchange, TLS, everything. So as a sufficient powerful quantum computer could use Shor's algorithm to crack, like I said, that like the 2048 in minutes, right? And then also it weakens the symmetric encryption system. Again, like I've given an example about the Grover's algorithm, how it gets weakened. And then also there is the third thing, harvest now and decrypt later. So this is the very scariest part. Attackers today are already stealing encrypted data, knowing what when quantum computers become powerful enough, they'll be able to decrypt it later. So long-term sensitive data like healthcare records, financial data, government secrets, all at risks. And then also the disease cert, the report says that 61% or more than 60% of organizations are worried about this, and this is with good reason. Now, how do we prepare for quantum computing security? So, what can we do about it? So, here are the five key strategies like I want to showcase here. The most promising long-term solution is the new cryptographic to come up with a new cryptographic algorithms that are resistant to both classic and quantum attacks. So in 2022, NIST selected four algorithms: the Crystal Cuber for key exchanges, Crystal Dilithium, Falcon, and Sphinx for digital signatures. So these are all part of post-quantum cryptography. Like there's a new cryptographic algorithms that the industry should embrace as opposed to the classic algorithms to prevent from the quantum attacks. And the second one is basically the quantum key distribution. This is a more exotic but very secure approach, using quantum mechanics itself to secure exchange keys. Any attempts to eavesdrop can be detected because measuring a quantum state changes it. QKDU is still limited, high cost, limited range, but promising for defense, finance, and government sectors. And the third one is basically using hybrid cryptographic systems. So in the near term, the best path is to combine traditional and quantum safe algorithms. So basically allowing backward compatibility while also gaining stronger protection. So Microsoft and Google are already testing this. For example, Kyber plus traditional TLS in Chrome and Azure environments. The fourth is basically the cloud vendor initiatives, right? So more major cloud providers are taking steps. Azure offers quantum safe VPN options. IBM Cloud, I think they're still in the testing phase for post-quantum algorithms. And AWS already provides a lot of cryptographic inventory tools and migration guidance. So basically, partnership with cloud vendors is key. Quantum readiness will increasingly be competitive. It will be increasingly competitive differentiated. So the fifth point is basically the cryptographic inventory and risk assessment. This is very critical. Organizations need to identify where encryption is used, what key lengths are in place, and where the sensitive data resides. Long-term data systems like healthcare, financial should be prioritized for updates. And then also zero trust architecture will also help reusing if there are in certain productions which are weak or broken. So we discussed about all these 5 points. Now let's talk about like how to prepare for quantum, post-quantum computing security. Like we discussed these 5 points. So now let's talk about the challenges. So this transition is not easy. There are three big challenges. One is compatibility, the migration cost, and risk of inaction. And with respect to compatibility, like many quantum safe algorithms don't work well with legacy systems and devices. And then also migration cost also will be significant investment. And then the risk of inaction is much higher than like the potential migration cost. So basically, the average cloud breach already costs like around like $4.4 million today. So once quantum attacks are practical, that could skyrocket. So doing nothing is the riskiest choice. So what is the path forward? So here are the practical steps every cloud-reliant organization should take now. The first is basically, like we discussed, like they implement hybrid encryption, then also monitor the NIST standards. NIST this and stay current like with as this post-quantum computing algorithms mature. And then also please collaborate with your cloud vendors such as your AWS, Microsoft, and IBM. And then also conduct crypto audits. So quantum computing again is no longer a science fiction. It's coming, and then cloud security teams need to start preparing now to stay ahead of the curve. Yeah, so to wrap up, so we are on the verge of quantum computing era and quantum era in the computing. So this brings enormous potential, but also significant risk to the security foundations of today's cloud environment. So by starting now through hybrid encryption, crypto audits, cloud partnerships, and zero trust, we can be ready. Quantum resilience will be a key pillar of cloud security in the years ahead. Thank you. And if you have any questions, please reach out to me or my email. Thank you.